Hi everyone, my name is Omer. I'm a co-founder at Zengo, and today I want to talk about secure multi-party computation. What I would like us to do is to go over a very simple example from real life that I hope would make this complex notion of MPC more understandable. So before we go to the example, let's revisit the dry definition. We have a set of parties, each one holds a piece of secret information or private input. Now the parties wish to jointly compute a function, and it can be any function, most likely a cryptographic function, over the inputs. And what we want to achieve is that at no point in time throughout the computation there's a leakage of their private inputs, while all parties learn the output. So let's look at a concrete example. Alice and Bob meet at a bar. Now they hit it off and everything is going nice and well, and towards the end of the night they wish to decide whether they should go on a second date. So this is a problem of a mutual affection. Now the easy way to solve it is for Alice to just tell Bob if she loves him or not, and for Bob to tell Alice if he loves her or not. In case both love each other, there's a happy ending and they can and we're done. But there's a catch, right? So let's look at the following situation. What happens if Alice loves Bob, but Bob does not love Alice back? This may turn out to be very embarrassing for Alice to reveal to Bob that she loves him. So let me explain what we're trying to avoid here from Alice's perspective. So Alice loves Bob in this specific case, and what it means is that of course she can tell if Bob loves her or not. But because Bob does not love her, we want to avoid the situation that Bob can tell if Alice loved him or not, such that we can avoid the embarrassment. Looking at it from a different angle, from Bob's perspective, so Bob decides that he does not love Alice. In this case, we want to make sure that he cannot distinguish between the case where Alice loved him or not. And how are we going to do it? So we're going to do it using MPC. Okay, so we are in a bar. Because we're in a bar, we'll use a deck of cards. Starting from the top left corner, if Alice decides that she loves Bob, she will pick Queen of Clubs followed by King of Hearts. And if Bob decides that he loves Alice, he will pick King of Hearts followed by Queen of Clubs. If they decide the other way, so they can just do the opposite, as you can see below. Right. So now we use another card, the fifth card. We'll put it in the middle. It's a King of Hearts. And Alice will take her two cards and put them upside down on top of this king. And Bob will take his two cards and put them below the king, again facing down. We then flip the king and we have a deck of 5 cards. Alice takes this deck somewhere private, so that Bob will not be able to see, and she's doing a very specific shuffling. So the only thing she can do is she can take the top card and move it to the bottom of the deck, and she can do it again and again. She can do it as many times as she would like, take the top card and move it to the bottom of the deck, as long as she does not reveal to Bob how many times she has done it. She then passes the deck to Bob, who is doing the same, exactly the same. So he's doing a shuffling again from the type of shuffling that moves the top of the deck to the bottom, and he can do it and repeat as many times as he would like, as long as he does not reveal to Alice how many times he has done it. Now let's open the cards and let's see the possible results. So as you can see, we have Alice here on the left and Bob on the right, and we aligned it using the middle card of the king. And as you can see in the option that both of them love each other, there's a mutual affection. This is the only option that we will find 3 kings in a row. So this is a clear signal for both of them that there's a mutual affection. At no other possibility you will get these 3 kings in a row. But what's more interesting is if we look at the other possibilities, right? And what we can notice is that all of them are basically the same option with different shifts, okay? So just look at a concrete example. Let's look at the second row where Alice does not love Bob. And you can see that the second row and the last row, the fourth one, are basically indistinguishable from one another. They're just one shift from, or a simple shift from one another. Therefore, Alice will not be able to tell whether Bob loved her or not, which is exactly what we wanted to achieve. Great. Let's revisit back the dry definition. So here we had 2 parties, Alice and Bob. The private information was basically 1 bit that indicated love, right? So if the bit was on or 1, it meant that there's love, and if it was 0, it meant no love. And the parties, the computation here was a basic AND gate, right? What does it mean? It means that if both bits were 1, or if it was love and love, then the output would be 1. But if at least one of the inputs were 0 or no love, then the output would be no love. But we cannot tell from the output what was the exact input, if it was no love and love, or it was no love, for example. Right? So this is got us exactly to where we wanted to achieve. Great. So hope it made the whole MPC thing much more understandable. Of course, there's much more to MPC, such as what happens if Alice or Bob try to cheat, right? This is a very important issue that needs to be considered, and many other security properties and fun stuff around it.